So today we would like to talk about analysis of interaction. So what is interaction? I think everybody knows 交互作用. So what is interaction? Remember in the last chapter, we talked about we can use adaptive model to predict the output of a factorial design. This is adaptive model. In this adaptive model, any combination can be predicted by using a summation of the average value and the main effects. And we have told you how to estimate this main effect. And we can use the difference between this average output in the response table minus the total average. This total average is also this constant in the adaptive model. So we just need to substitute any combination in that factorial by the corresponding main effects. We can estimate the output. And in this model, all the effects are independent, because it is a linear model. So the output will be a summation of each main effects. Therefore, they are independent. One selection of a factor will not affect another selection of our factors. When there is no interaction between two factors, this is one of the case. This is L4, not L4, two factors, two level, and this is a full factorial because we have four combination. And we want to understand what is the inference for each factor to the output. If there is no interaction, then the effect of one factors on the output will be independent from the selection of another factors. Let's show you this example. For instance, we want to understand that what is the response difference? What will be the difference if I change the selection of A from A1 to A2? So there are two cases. When B is in B1, combination 1, A is in level 1, combination 3, A is in level 2. So the difference when I change from A1 to A2 will be 20, right? When B is in B1. When B is in B1. Then when B is in B1, so I change A from A1 to A2, the corresponding output will change from 20 to 40. Therefore, the difference will be 20. But if I consider another case, when B is in B2, which is R, experiment number 2 and experiment number 4. For these two experiments, B are all in B2, but experiment number 2, A is in A1, 4, A is in A2. So the difference between these two experiments is due to I change from A1 to A2. And the difference are 50 minus 30, they are 20. And you will find out that this 20 is the same as another one when B is in B1. Therefore, the conclusion is the difference will be the same, no matter B is in level 1 or B is in level 2. The inference of A to the output will be the same. Okay, will be the same. Therefore, we can see A and B, they are independent. There is no interaction if the difference are the same. And when there are no interaction, adaptive model will hold, which means that the adaptive model will give us a very good prediction. Again, let's use this example. If for this L4, the adaptive model will look like this because we have only two control factors. And this is the adaptive model. So here, When I change, consider the last page, when I change A1 to A2, when B is in B1, what will be the difference if I use this adaptive model to predict? We can substitute that into the equation. The difference will be 2, 1 minus 1, 1, right? Because level factor B is in level 1. But here 2, 1 is A in level 2, 1, 1, A in level 1. We use Yij here to stand for the selection of level A and level B, I and J. So A level 2, B level 1. So the only difference, so we can substitute that into the data model. 2, 1 can be estimated using this equation. Again, 1, 1 can be estimated using this equation. When we clean it up, we find out using that adaptive model, the difference will be A2 minus A1. Okay, this B are canceled out. And if I ask you the same questions, what will be the difference when I change A1 to A2, but in this case, B is set at level 2? We can also use the model to predict. Here, 1, 2, 2, 2, right? So the difference will be 2, 2 minus 1, 2. And using this model, 2, 2, substitute into the adaptive model will be this one. 1, 2 will be that one. Again, mu cancel out, B2 cancel out. The only difference will be A2 minus A1. Therefore, you can find out if the adaptive model is accurate. I can use this model to predict the difference. And you can find out the difference in this case will be the same. So in another way, if from the experiment, this is from the model, if from the experiment, we find out that the difference are the same, which can indicate our predictive model is accurate, right? Because our predictive model say these two will be the same, and exactly they are the same. Therefore, we will say that the adaptive model in this case is very good to estimate the output. And also, there will be no interaction, right? So, no interaction. If adaptive model, what should say? If there are no interaction, then you can use adaptive model to predict any factorial output. All right, this is another case. If there are interaction, what will happen? There are two factors, C and D, two level, and the total combination will be 4 combination. And let's see if C and D are independent or not. Let's try the first one. Let's look at the difference between C1 to C2. Change from C1 to C2. When D is in D1, will be experiment 1 and experiment 3. And the corresponding output is 20 and 40. So the difference between experiment 1 and experiment 3 is C is changed from C1 to C2, right? D is the same, but C changed from C1 to C2. So we can conclude that the difference will be due to the change of C, and the difference is 20. Again, let's look at another case. When D is in D2, which is experiment 2 and 4, like what we did before. And the difference in this case will be 10 minus 45, which is minus 35. This shows that these two numbers are very different. Why they are different? If the adaptive model is correct, these two numbers should be identical, should be the same. But now these two numbers are very different, which indicate that there are interaction between C and D. Or the difference between C1 and C2 will depend the selection, the setting of D. If D is in D2, the difference will be minus 35. If D is D1, the difference will be 20. Now we have a problem. Whether C1 is better or C2 is better is not a clear answer. It depends how we select D first. If we select D2, the difference will be 20, which means that C2 is larger than C1. But if D is in D2, you will find out that C2 is smaller than C1. So when we want to determine whether C is in level 1 or level 2, we will be confused. We don't know which factor is the best parameter design. That's the reason why interaction will have an influence to our selection of the optimum combination. So in this case, C and D have some interaction. So now we understand that the interaction will have influence. Here we have a conclusion, although I already told you before. Adaptive model will fail if there are interaction. Here again, we check that the CD case. This is adaptive model for C and D in 2 level. And in our previous example, what's the difference between C1 and C2? When D is in D1, we substitute into that model. We know that the difference using the adaptive model should be C2 minus C1. Again, this is the number from the experiment, 20. But when D is in D2, using the adaptive model, we predict the difference will be again C1 and C2, difference between C1 and C2. But the actual number will be minus 35. So this conclusion is different from the conclusion from the adaptive model, which means that our adaptive model is incorrect. Okay? So here tells that if there's interaction, the adaptive model cannot accurately predict the output. Now, then we might get into trouble because we use the concept of adaptive model to predict what will be the best combination of our parameters. So here, what is interaction? Interaction means that the effect of one factors will depend on the level of another factors. So we need to understand that if there is an interaction or not before we can say that our prediction is correct or incorrect. Therefore, we will teach you how to draw the interaction plot. So as I mentioned, if there's no interaction, then the adaptive model will be good. And the effect changing from one level to another level will be independent from the selection of another factors. And the model will be independent from each other. The main effect will be independent from each other. But if there is an interaction, which means that the factors are not independent, interaction not independent, then the prediction output using this model will be incorrect, which means that we'll have large error, just like what I said here. Okay. So then we want to introduce how to use a two-way interaction plot to understand whether they are interaction or not. So here we will use this example of 2 level. If A and B are 2 level, then we will have 4 combinations. So we can come up this combination table, A1, A2, B1, B2, and to find out what is the average of each combination. So we are using analysis of mean, but for this 2-factor combination. We want to understand what is the average output when A1, A2 in different combination. So here, from this table, after we come up with this table, we can draw the interaction plot. From this interaction plot, we can understand whether these two factors has interaction or not, and also which type of interaction. The horizontal is one factor, and there are two lines depends on another factors, when another factor in level 1 or level 2. Okay, we will use this example later. So this is what we are going to do. So I'm going to use Excel directly to show you how to draw the interaction plot. Then we can come back to the PPT. All right, so please, okay, so please open your file, Excel file. This is the file that shown in the table. Very similar, although the number might be different. Let's see. Okay, the number will be different. That's all right. 30, 35, 30. Okay, number are a little bit different. That's okay. Let me see. Do you want to change it back to the same? No, that's all right. Okay. Although these numbers are different from the lecture notes, we can come up the same. We just use this one as an example. All right. We can first come up the response table first. I think it should be very easy. A1, C1. Here, I just using average directly. When A is in A1, C is in C1, we can look at the table. There are first two experiments when A in A1, C is in A1 as well. So here, the average output when A1, C1 will be average, the first two. Then you can finish this analysis of mean for this AC interaction. Okay, very straightforward, right? Then we can start draw the AC interaction plot. It's very easy. Select the whole table. Then insert. Remember, this one we should select this line plot, this one. Because A1, A2 are not continuous number. They are factorial factor already. So they are factor 1, factor 2. So we can select this one. If you prefer this a dot, we can select this one. Now you can have this interaction plot. Let's move it down here. And again, I would suggest you to make the title, indicate the title, so you'll know what kind of plot it is. Okay? Any questions? If you have any questions, please raise your hand. Very good. I think most of you have already found out the interaction plot. So from this interaction plot, we can understand whether they are interaction or not. Later on in the PPT, it will show you that we can see if these two lines are parallel to each other, then there will be no interaction. But here, this case, these two lines are not parallel to each other. So we'll say A and C will have interaction. And again, in this case, you can see that the horizontal is C1, C2, and the blue line is A1, red line is A2. Okay? We can change the presentation of the figure by changing the horizontal to A1 and A2 if you want. So here, we can make a right click and we can change the type. Select the data. Select data. From the selection of data, we can switch column and row. Click OK. And you will find out that the horizontal line will become A1 and A2. And these two lines will be C1 and C2 respectively. Okay, this is how you change. You can change that back. Let me do that again. Selection of data, click and switch column and row. Then you can change it back. Any questions? Or before I continue, I want you to practice again by yourself by work out what is the interaction plot of A and D. Following the similar process, I want you to find out what is the interaction plot for A and D. After you finish that, please make a screen copy of your A and D. I just need A and D to the Zuvio, so I know you will know how to do it. So please come up this interaction combination table and the interaction plot for AD. Yeah, and this student, he provide two figures. One is AD, another one is DA. But you will find out that the conclusion should be the same. I will show you the conclusion later. Combination, right? So therefore, there's another way to check whether we did that correctly or not. You will know that there are two combinations for each cell. So we can take the average of these four. Should be the same as the average, total average. Here, what is the total average? You can say the total average is equal to 46.375. So here you can double check. You can take the average of these four cells, enter. And these two numbers should be the same. This is the average of these four, okay? And this is the average of the total 8 experiments. These two should be the same because two combination, actually they are average of total 8 combination. So these two numbers should be the same. So we can use this one as a double check to see if your selection is correct or not. If they are the same, they are correct. So you can do the same thing for A and D. So this is the PPT that is showing the process to draw the interaction plot. So here we can come up this analysis of mean for this interaction A and B. Interaction A and B. And here, say A1, B1 will be the average of A1, B1, these two experiments. Same thing for these two. We already did that. So we can draw the line, and here we can see there are two lines. When A is in A1, this is the blue. The red line is A in A2. This shows the difference when I change B1 to B2. Okay? And here, if you draw the average of B1, B2, this is an effect plot of B1, B2. And you will find out that B1, B2 is actually in the middle of these two lines. Or we should say that this interaction plot is to split the effect plot of B1, B2 into two lines. First line is when A in A1. Second line is when A is in A2. So there will be some relationship between these two. So let's look at this curve. If there is no interaction, just like this case before, we showed that there is no interaction in our previous example. And if you draw the interaction plot for this case, you can find out that the interaction plot will look like this one. These two lines are parallel. So here, we can observe from the interaction plot that if these two lines are parallel, okay, there will be no interaction. Why? Because the difference when I change from B1 to B2 is this much. When, I'm sorry, from A1 to A2, when B is B1 is this much. But when B is in B2, it's the same, right? The difference is the same. Therefore, these two lines will be parallel. If they are the same, means that there will be no interaction, or the inference of these factors will be the same, no matter what is the selection of another factor. Okay, so if they are interaction, what does it look like for your interaction plot? If they are interaction, then they will be not parallel. Okay, if they are not parallel, if they are interaction, then the adaptive model will be incorrect. Okay, and there are two types of interaction: synergistic and anti-synergistic. The translation will be synergistic and anti-synergistic. And let's look at what will be the inference if you have interaction. This is called synergistic interaction. If you can see they are not parallel because the difference are different. Okay, because the difference are different. The difference from B1 to B2, I'm sorry, from A1 to A2, in this case, the difference is this much. Okay, delta. When I change A1 to A2, the difference will be this much if B is in B1. But if B is in B2, you can see the difference will become bigger. And you can see these two differences are not the same. If they are the same, these two lines will be parallel. They are not the same, so these two lines are not parallel. Okay? But in this case, let's execute the optimal design questions. If you want to select factor A, you want to select A1, A2. Which one is better? Which one is better? A1 better or A2 is better? If you want to increase your SN ratio, which level should you select? A1 or A2? A2, yes, because A2 is bigger, right? A2 is bigger than A1, even though they are different. But even though B in B2, the selection will be the same, you still think A2 is better than A1. This is what they say here. The selection, optimum selection of A doesn't change, even though B changed from B1 to B2. Okay, so if they are synergistic, the selection of optimum level still the same, will not change. Okay, this is when we have synergistic interaction. The optimum selection of each level for this A1 will still the same. You might be interested that how about B? The selection of B will be the same no matter whether they are A1 or A2. Well, you can change your curve. Let's go back to the interaction plot. And to find out, let's borrow his figure to answer the questions. Here you can see we have two interaction plots. They are A and D, interaction plot for AD. This is when horizontal is A, this is when horizontal axis is D, right? They are interaction plot for AD. So this is what? Synergistic interaction, right? Synergistic because these two lines are not parallel, but the slope direction, the slope, the sign of the slope are the same. This is positive slope, they are the same. So here let's see, A1 and A2, which one will be better? Will you select A1 or A2? Just like what I just asked you, right? A2 is better because A2 has a large output, even though there are two lines. First one is D1, the second one, the red line is D2. No matter D1 or D2, the selection of A, still A2 is higher than A1. I say interaction A and D, right? So D has no influence on the selection. I should say that the D will have some influence on the selection, on the output of A, but it doesn't change the selection of A. A2 is still better than A1. How about D? D1, D2 in this curve. Which one is better, D1 or D2? D1 or D2? D2, yes, because D2 is larger than D1. There are two lines, doesn't matter. This is A1, this is A2. When A is in A1, the selection of D2 is still better than D1. When A is in A2, the red line, the selection of D2 is still higher than D1. So they are synergistic interaction. So let's come back to this one. As I say that this is called synergistic, all right? And the synergistic, although the difference is different, okay? Although the difference are not the same, they are not parallel. However, the selection of A still the same, no matter B1 or B2, which will be the same as the effect plot. The red line here, this one is the effect plot, A1, A2. And you can find out in the effect plot, you select A2. Because in the effect plot, we assume all the factors are independent. But when we consider the interaction of A1 and A and B, we have two lines. Unfortunately, even though there are some interaction, the selection of A still the same as the selection from the effect plot. Okay, let's come back to this problem. Okay, let's take a 10 minutes break, but during the break, I will want you to finish this table. Okay, finish this response table. And we will use this one to continue our discussion regarding the inference for interaction. Okay, let's take a 10 minutes break. All right, I already finished the effect plot and also the interaction AD. So let's look at the effect plot. In the past, okay, let's look at this effect plot. In the past, we are using effect plot to select the optimum level for each factors. So in this case, say D, this is a effect plot, D1, D2. I believe you will select D2, right? Because D2 here has a larger output, all right? D2 will have a larger output. Now, we have drawn the interaction plot. And we want to find out that whether A and D has an interaction. And you can see that A and D are not parallel. They are very close, but they are not parallel. Therefore, they are interaction. What type of interaction? Synergistic, right? They are synergistic interaction for A and D. Even though they are synergistic interaction, if I ask you the questions, whether D1 and D2, which one is better? D1, D2, which one is better? You will give me the same conclusion that D2 is better than D1, even though there are two lines. But these two lines tell you the same thing. D2 is better than D1, and that conclusion is the same as the effect plot. It's the same as the effect plot, right? So you can roughly know, just like what I just showed you in the transparency, you can roughly know that this is a response plot, this is effect plot. And this is the interaction plot. if they have synergistic interaction. Synergistic interaction. You can see that the selection of A, no matter B1 or B2, they are the same. A2 is better than A1, which is the same as the effect plot. Effect plot looks like the middle line. Okay, the middle line between these two interaction plots. Or you can see that the interaction plot is to split this effect plot into two lines. One case is B in level 1, the other case B in level 2. And because the slope, the direction of the slope, they are all positive slope. Therefore, the slope remain the same. Okay, 斜率 slope remain the same. Therefore, the selection of optimum level remain the same. This is interaction plot. But if you have anti-synergistic, from the effect plot, you might have something like this. If you have anti-synergistic, we can use the Excel example later. A1, A2 in the effect plot will look like that. But in the interaction plot, it might look like this one, when B in B1, when B is set at level 1, but will look like very different when B is in level 2. You can see this has a positive slope, but here, when B is in B2, there's a negative slope. So we can see that the slope will change direction. In this case, we call this anti-synergistic. So when in the interaction plot, we will say that they have anti-synergistic. When they have anti-synergistic, you conclude that the selection of the optimum level need to consider these two interaction factors simultaneously. Why did I say that? Because when I execute the questions, A1 and A2, which one is better? Should you select A2 or A1? You will say that it depends. Depends what? Depends whether you are talking about B1 or B2. If B is in level 1, then A1, A2, you will say that A2 is better, right? A2 bigger than A1 if B is in level 1. However, if B is in level 2, then B1 and A1, A2, which one is better? A1 is better. So your conclusion will be different. If B is in B1, you will select A2. But if B is in B2, you will select A1. Which means that the anti-synergistic will influence your optimum combination, your selection of the optimum combination. If you use, let's look at that. If you use the effect plot, this is effect plot. The effect plot might tell you that A1 is better than A2. A1 is better than A2. So from the effect plot, you select A1. But due to interaction between A and B, if your B is select B1, then you should select A2 instead of A1. Okay? So you know that the selection of the optimum level will be different from the effect plot. But let me ask you the question, whether A should be select A1 or A2. I will say that A and B, which one is the best? You should consider these two factors simultaneously. That is why we have this interaction analysis mean for this interaction. Since we have the average output for these four combinations, right? So now you need to select A and B simultaneously, continuously. Which one is better? Which one is better? Which combination is better? A and B. You need to look at A and B simultaneously. How do we do? Look at this 4 number. This 4 combination. Which combination will give you the highest SN ratio? This one, right? This one will give you the largest, highest. And which combination it is? This is A2, B1. So here you should select A2 and B1. And this conclusion is from the interaction plot. You cannot look at the effect plot. Okay, you cannot look at the effect plot because in the effect plot, it tells you that A1 is better. See, A1 is better. And this effect plot you can see is the center line between here and there, right? This line. Okay. So, if they are anti-synergistic, the slope of one factors will change sign. So the optimum setting for one factor will depend on another. A and B would depend, the selection of A would depend your selection of B. Therefore, we need to consider these 2 factors simultaneously. Any questions? So if you have interaction like here, you can see there will be a change of slope sign. From positive, this is a positive slope, and this is negative slope, okay? They change. Oh, sorry. I should switch to here. Okay, if they are anti-synergistic, the slope will change sign from positive to negative. All right. Any questions? Then let's come back to if there are 3 levels, the interaction product will be similar, although a little bit more complicated. Here, if A1, A and B are all 3 levels, if you can follow the similar process, you can get an analysis of mean for interaction AB. You have 3 by 3 table, 9 combination. So we can draw the AB interaction product following the similar process, and this is the product you will have. If similar to the 2 levels, if these 2 lines are parallel like this one, then there will be no interaction. If they are parallel, there will be no interaction. However, there are 3 levels. So they are not just 2 lines. They are here 1, 2, 3, 4, 5, 6 segments of line. So you need to compare line by line. You need to see these 2 lines, if they are parallel or not. And another one is these 2 lines, if they are parallel or not. So you need to make two comparisons from A1 to A2. Similar, from A2 to A3, there are 3 lines. You need to make comparison whether these 2 lines are parallel or not, and then this line and that line. Therefore, you need to make 4 comparisons. Some might be confused that why, if you consider this and that, why not these 2 lines? Because you can get a conclusion from the previous 2 comparisons. We will talk about that later, all right? But if they are not parallel, like this one, they are not parallel. And it is not as easy in our previous case that there are only 2 lines to compare. We have 6 lines. Therefore, the not parallel will be a little bit more complicated to determine how not parallel. But in this case, they are still synergistic. What do I mean by synergistic? The slope sign are still the same, positive, positive, positive. Okay, they are all positive. The slope sign are all the same. If you have lines like that, they are called anti-synergistic. As you can see, this line has a positive slope, but B3, that line has a negative slope, right? Negative slope, positive slope. So the sign of the slope change. Therefore, we say they are anti-synergistic. The conclusion will be similar to the two level. Any question? All right. So here in the parameter design, as I mentioned before, although the model is not accurate, although the difference depends on B1 or B2. The difference depends on whether you select B1 or B2, but the selection of A still the same, right? Selection of A2 is better. A2 is better. And B2 is better. As you can see here, B2 is always higher than B1. So B2 is better. The selection of A and B will be the same as the effect plot if they are synergistic. The selection will be the same because in the effect plot, we will select A2 and B2. How about in the interaction plot? In the interaction plot, there are 4 combinations. And we can see this one will give us the largest output. And this combination is B2, A2. See? The same. Effect plot tells us A2, B2. And here, in the interaction plot, this combination gives us the largest output. And this combination is A2, B2, the same. They are the same. So if they are synergistic interaction, they are okay. Okay. You can still get the best combination in your optimum design. However, you are not as lucky if you have a anti-synergistic. Just like what I mentioned, this is anti-synergistic. As you can see, the slope change sign from positive to negative. Therefore, the selection of A and B will be more complicated because look at here. For the effect plot, you will select A1, B1, right? A1, B1. For the effect plot. However, for the interaction plot, you know, there's a anti-synergistic. They are anti-synergistic. So the selection will be different. How different? Let's look at the interaction plot. In the interaction plot, which combination tells us will have the highest output? This combination, right? This combination is the highest. This one is the lowest. So increase greater. So this combination is the best. What combination? A2, B1. So here, it tells you A2, B1 is the best from the interaction plot. And you find out that these two numbers are not the same. See, they are not the same. Which means that if they are anti-synergistic, your prediction of the optimum combination using effect plot could be incorrect. Okay? Could be incorrect. Any problem? So the conclusions are different. Which one should we follow? We should follow the interaction plot because they are interaction. The adaptive model will fail. So we should use interaction plot. However, they are a little bit more complicated because the interaction is not just A and B. We should consider A and B and also A and C and also A and D, right? So the selection of A does not just consider factor B. We should also consider some other factor too. if there are more interactions. Okay, so here, this is a kind of summary. There will be no interaction. The interaction plot will be parallel. And this is the effect plot. I use dot line to represent the effect plot. You can see these three lines will give you the same story. The difference are the same. The conclusion will be the same too. Here, if there are interaction, in this case, if they are synergistic, anti-synergistic, this is anti-synergistic, be careful. Although you can look at this curve, you can see that these two lines looks like that they are all positive slope. You might say that A and B has a synergistic interaction. However, if you see that there is an intersection, 交叉, if these two lines has an intersection, then these two lines will have anti-synergistic interaction. Why? You can change the horizontal axis to B, and you can see that these two lines has different slope. Although even A1, the selection of A1 and A2 doesn't influence by the B. However, the selection of B will be influenced by A. Then we should consider AB simultaneously, which means that they are anti-synergistic. So be careful. When you look at two lines, so be careful if these two lines has intersections, even though they didn't change sign, they are still anti-synergistic. You can double check by changing the horizontal axis. You will see they are sign change, the slope change from positive to negative. Okay. So when they are anti-synergistic, you can see the optimum combination will be different. Just like we said, from the effect plot will be different from the interaction table, from the interaction plot. But if there are no interaction, the optimum combination will remain the same. Doesn't matter you are choosing from effect plot or from the interaction plot. Okay, so this will be corresponding to the 4 cases we mentioned in our last week. So here in case 1 and 2, case 1 and case 2, which means that the prediction are very accurate. We just look at again. We only look at again, will be easier. So if they are the same, we might say that there are no interaction. But if they are different, case 3 and case 4. In case 3, it is different. However, I mentioned that the optimum setting are still okay, which means that the model is incorrect, but the optimal selection is still okay. Why? There might be interaction, but this will be synergistic interaction. If your case was case 4, the selection not just, okay, is case 4. You will know that the model is incorrect. The model predict 20, but actually is very different from 20. And is in the bad way, which means that it's much smaller than the prediction. This is very possible that you have anti-synergistic. And your optimum combination will be incorrect. Okay, your optimum combination from the effect plot, from the effect plot will be different, and your optimum settings will be incorrect. Okay, you therefore, if it is case, so Taguchi kind of using verification table first before go to the interaction analysis. During the verification of the optimum, if it is case 3 or case 4, means that you might be in trouble, especially if it is case 4. Then, if you want to find out what happened, you should use interaction analysis, using the international interaction analysis for case 3 and case 4 to determine which two factors has interaction and whether this interaction is synergistic or anti-synergistic. But the problem, or I should say the premise means the assumption, 前提. When you do this, the assumption is the interaction can be estimated. The interaction can be estimated. What does that mean? I will show you later. Okay, so here so as you can see that this is adaptive model. We only consider many facts. If in the future you want to consider the interactions, your model need to change to a bigger model to include not just many facts, but also these interaction effects. Interaction effects. And if these interaction effects are big or significant, you should include that into your model, which means that your model will have more variables. More variables means that you need to have more experiment in your orthogonal array in order to estimate these unknown variables. Okay, so I don't want to go too much detail, but I want to use this section to introduce what is confounding of effect. What is confounding of effects? Since we are using fractional factorial, we are using smaller experiment to predict our output, which means that we kind of have a lot of assumptions. One of the assumptions is no interactions. If there are interactions, then our prediction, our estimation of model or estimation of effects need a bigger experiment, need a bigger orthogonal array in order to find out what is the interaction effects. If you don't have a bigger experiments, they will result in confounding of many effects and interaction effects. I will show you what does that mean by confounding of interaction effects and many effects, which means that you cannot separate during the analysis. You cannot separate that whether it is due to many effect or due to interaction. Okay, you cannot differentiate. If you want to analyze the result, you need to make sure that there will be no confounding, or the confounding effects, one of the confounding effects will be negligible. I will talk about that later. Let's look at this example first, then we go back to the conclusion. Here you can see this is the interaction plot for A and B. As I mentioned before, these two lines are not parallel because they are interaction, but this is synergistic interaction. And they are not the same. Here, when you change from A1 to A2, if B is in B1, the difference is B1. If B is in B2, the difference will be D2. Therefore, whether they are interaction or not can be determined by the difference between D1 and D2. If D1 equal to D2, if these two numbers are the same, then these two lines will be parallel, no interaction. If they are not the same, they are interaction. Okay? If they are changing sign, they are very different, one positive or one negative, then there might be anti-synergistic. So how do we find out how strong the interaction is? We can, for two-level factors, we can use the difference between D2 and D1 to determine how strong the interaction is. Okay, so here we want to find out what is the difference between D2 and D1. What is D2? The average of A2, B2. minus the average of A1, B2. And what is D1? So we can rearrange that. The difference between D2 and D1 will be A2, B2 plus A1, B1 minus A2, B1 plus A1, B2. Okay? Then let's look at your arrangement of experiment in your orthogonal array. Let's assume A in column 1, B in column 2. If you arrange A in column 1, B in column 2, then what will be the difference between D2 minus D1? There will be the difference between, this can be estimated by using this equation. So let's continue. What is A2B2? A2B2 is the average of Y7 and Y8, right? What is A1B1? Response table. Average of Y1 and Y2. Therefore, the difference between D1, D2 can be estimated using this equation. So let's come back to the effect plot. During the effect plot, if you arrange A in column 1, B in column 2, but C in column 3, what happened? If you want to ask you to say, what is the difference when I change C from level 1 to level 2? This is the effect plot, right? From level 1 to level 2. What is the difference between C1 and C2? C1 is the average of level 1, 1, 2, 7, 8. The average of 1, 2, 7, 8. Same thing, C2. So rearrange this equation. You can find out in the effect plot, if you want to determine whether main effect of C is strong or weak, we can use in this equation. Let's go back to the interaction. From our last page, we assign A to column 1, B to column 2, and we conclude that the interaction, the difference between these two lines, can be estimated using this equation, right? If you compare this and that, you can find out these two equations are what? They are dependent. This big, this will also big because this is 1, 2, 7, 8 minus 3, 4, 5, 6. You see, they are dependent, 相依. Therefore, increase if the effect, the difference, the main effect of C is strong, the interaction is strong. Or I should put it another way. You cannot say that you don't know the difference of this is big, whether it is due to main effect C or due to interaction AB. The interaction AB in this case is mixed up with effect C. You cannot separate effect C with interaction AB. So we'll say that these two effects, AB interaction and effect C, okay, if you put C in column 3, these two will be confounded, You cannot accurately estimate C or interaction AB. Okay, so this interaction, the confounding, will be due to the different arrangement of A, B, C in your L8. But if you change the arrangement, because we know that interaction A and B will be very similar to the factor if you put in column 3. So we want to avoid the confounding of C and AB. We can put C in different column, such as we put C in column 4. If we move C to column 4, then the estimation of main effect C will not be related to the interaction AB. Okay, so this is the trick. If you make different arrangement, we don't want to put C in column 3, we put it in different column, then we can avoid this kind of confounding. Since AB will confound with any factor assigned to column 3. Since column 3, you can see 1, 2, 7, 8, column 3, 1, 2, 7, 8, minus 2, 3, 4, 5, 6. So if you assign any factor to column 3, when you estimate the main effects, you have the similar equation to the interaction AB. Okay, so now let's go back to this one. Okay, let's continue. So here, if they are interactions, we need to find out the confounding structure first to make sure to kind of spread out our factors. Doesn't want to mix with the interaction with our main effects. How do we do? Taguchi, instead of using the analysis I just showed you, Taguchi proposed an interaction table for every orthogonal array. This is the interaction table for L8. Okay, so if you assign any factor to 1 and 2, the interaction will confound with any factor in column 3. So you can use this interaction table to come up the confounding structure. We call the confounding structure. I will use an example to show you how to do that. Just like what we did, okay, just like what I explained in the quiz. If you assign A to 1, B to column 2, sorry, A, B, and the interaction AB will confound with any factor in column 3. So you can use this one to come up where the interaction will be. Okay, just like here. So let's give you an exercise. If you arrange A in column 1, B in column 2, C in column 4, I want you to use this interaction table to find out where is the interaction will be, or I should say, I want you to find out the confounding structure. Let me give you some hint. 1, 2, 3, 4, 5, 6, 7. Just like our previous exercise, A, B, and C. So we can use that interaction table to find out the interaction of A and B. Where is A and B? Since A is put in the column 1, B is in column 2, so the interaction will happen in column 3. So here you can find out the interaction of AB will be in column 3. Any questions? How many interactions do we have? We have 3 factors. So how many interactions? C, 3 by 2 will be 3, 2, 2, 1. So there will be total 3 combinations. Very easy. AB, AC, and BC. Very simple. So please finish that. Use this interaction table to find out the confounding structure. Okay, 有人已经睡着了，所以我们让这个 using this example, please find out the confounding structures and fill out the form and find out. Fill out this form similar to this one in your lecture note and upload that into the Zooview. Here, A, B, C are assigned to 1, 2, 4. So please find out the confounding structure. I have almost finished that for you. And there are 2 more interactions. Find out where are these 2 interactions is. And please assign to this column and fill it out in the Zooview. This is only example, okay? It doesn't mean that there will be another interaction in column 1, but you just need to find out A, B, C, and where is AB? Where is AC? Where is BC? This is very simple. Okay, this is very simple. I think you should finish that in maybe 2 minutes. Since there are only 2 more interactions. Since we only have 3 factors, so there are only 2 factors interaction. You just need to fill out the table. 1, 2, 3, 4, 5, 6, 7, and A column 1, B column 2, C column 4, and where's AB? Where's BC? Where's AC? I already make one for you. AB were in column 3. Where is AC? Where is BC? Very simple. Should be very straightforward. I just want to know whether you know how to use the interaction table. So where is AC? A in column 1, C in column 4. So the interaction of column 1 and column 4 will happen in which column? You can find out from the interaction table. And similarly, where is the interaction BC? Okay, let's look at the result. There are only 10 persons answer the questions, right? And you can see the first one, Meng Hui, is correct. AB, D3, AC, number 5. Why AC is in number 5? I think you can look at the table. Let's go back to the PPT. A, B, C. So here we want to find out where is the interaction A and B. A in column 1, B in column 2. So look at the interaction table. Interaction AB, column 1, column 2. So let's from here first. 1, 2 will happen in column 3. So here, AB, column 3. How about AC? A, column 1, C in column 4. So column 1 and column 4, the interaction will happen in column 5. So AC will be in column 5. Do the same thing for BC. You should be finished. You'll be able to finish that the interaction ABC will be in column 6. If you are 3 level, just like this one, this is L9, and this is the interaction table for L9. As I mentioned before, the interaction of L9 will happen in 2 columns. One, if you assign A to column 1, B to column 2, then the interaction of AB 1 and 2 will happen in column 3 and column 4. So the interaction of AB will happen in 2 columns. As I mentioned before, you need more degree of freedom, or I should say, you have more unknown variables if you want to look at the interaction AB for the 3 level. Since for 3 level, there will be 6 line segments. Remember, 6 line segments. So you need to have more comparison. So the confounding structure will look like that. You can look at the confounding structure. You will know that whether you can analyze A and B, also interaction AB. For this case, A and B and interaction AB, they are all separated. Just like the previous example here. If you do this assignment, A, B, C, and interaction AB, AC, BC, they are all separated, which means that there will be no confounding, which means that you can analyze main effects and also you can analyze interaction effects. You can estimate both main effects and interaction effects. However, if the main effects are confounding with one of the interaction effect, then you cannot separate these two, which means that you cannot estimate, if they are confounding, you cannot estimate main effects or interaction effects correctly. We will talk about more in next week lecture. And this is L9. If you look at this is L16, interaction table for L16. A bigger one, but the way to use that is very similar to L4, and this is L27. Again, this is three-level factor, so any two factor interaction will occupy two columns. Okay, will occupy two columns. Okay, there are two special orthogonal arrays, L18 and L12. You will see that there is no interaction table for Taguchi because these two orthogonal arrays are special orthogonal arrays. They cannot estimate interaction. Okay, you can, if you are using L12 and L18, they are special orthogonal arrays. You cannot use, if you are using these two, you cannot estimate the interaction effects. Since the interaction effects are evenly distributed into each columns, you cannot use a similar way to estimate the interaction effect, which means that you cannot draw the interaction plot if you are using L12 or L18. Okay. So if you are using L12 and L18, and in the verification of optima, you find out that your results are very different, then you need to redo the experiment if you want to analyze the interaction. And this is L12, okay? L12. No interaction, right? As you can see, if you want to estimate interaction, you cannot use L12. Same thing, you cannot use LT18. Okay, I'll finish here. We will continue the interaction analysis next week, since what happens if there are interaction? As you know that we can assign our factors to different columns, which will result in different confounding structures. So we will use this kind of property to assign our factors in such a way that the main effects and the interaction effects we want to analyze can be estimated, which means that there will be no confounding for our main effects and interaction. How can we do that? We will talk about that next week. All right, see you next week.